Chapter 7 P Block Elements 12 Signs Part 11 Compounds of Group 16.
Hello students, I am Madhusina, your chemistry teacher. Watch my YouTube videos, like and subscribe it for further notification. With the help of upcoming video, let us study about the compounds of group number 16, their properties and uses.
In free and combined state. Nearly all rocks, clays, and many minerals contain a high proportion of oxygen. Preparation of dioxygen can be done by following methods. By the action of heat on certain metal oxides. By the action of heat on certain alkali salts which contain oxygen. By decomposition of H2O2. On commercial scale, dioxygen is manufactured by electrolysis of water. By fractional distillation of liquid air. When liquid air is distilled, nitrogen with lower boiling point distills out first, leaving behind practically pure dioxygen. Properties of dioxygen. It is a colorless, odorless, and tasteless gas. It is slightly soluble in water, which gives vital support to marine and aquatic life. It is very reactive. The reaction rate increases with temperature and in presence of the catalyst. All metals in electrochemical series combine directly with oxygen to give oxides. Sulfur, phosphorus, and carbon burn rapidly in dioxygen, forming their oxides. Many compounds also react with oxygen. Uses of dioxygen. It is used in breathing apparatus. Oxygen cylinders are widely used in hospitals, high-altitude flying, and in mountaineering. It is used in burning of fuels. It is used in production of steel. It is used as an oxidizing agent. It is used in welding torches. Simple oxides. A binary compound of oxygen with another element is called oxide. Oxygen combines with most of the elements to form oxides. An element having variable valency forms many oxides. For example, PbO, PbO2, and Pb3O4. On the basis of their nature, oxides can be classified as follows. Basic oxides. An oxide which dissolves in water to give an alkaline solution or reacts with an acid to form salt is called a basic oxide. For example, Na2O, K2O, MgO, and CaO. Acidic oxides. These oxides, when dissolved in water, give acidic solution, or if not soluble in water, then react with a base to form salt in water. For example, SO2, N2O3, P2O3, and Br2O. The acidity of the oxide increases as the oxidation number increases. Amphoteric oxides. Some oxides show characteristics of both acidic as well as basic oxides. For example, ZNO, Al2O3, GeO, and PbO2. Neutral oxides. Those oxides which are neither acidic nor basic are called neutral oxides. For example, CO, NO, N2O, and H2O. Ozone. Ozone is allotropic form of oxygen. Under certain conditions, 3 atoms of oxygen combine together to form triatomic molecule of ozone. When a dry, slow stream of oxygen is passed through a silent electric discharge, there is partial conversion of oxygen into ozone. Since the formation of ozone from oxygen is an endothermic process, it is necessary to use silent electric discharge. The apparatus used to obtain ozone is called ozonizer. Siemens ozonizer. It consists of two coaxial glass tubes sealed at one end. The inner surface of the inner tube and outer surface of the outer tube are coated with tin foil. It gives 10 to 15% ozone-oxygen mixture. Properties of ozone. Pure ozone is a pale blue gas with a characteristic pungent smell. It is slightly soluble in water. Ozone is thermodynamically unstable with respect to oxygen, since its decomposition into oxygen results in liberation of heat and an increase in entropy. Due to ease with which ozone can liberate an atom of oxygen, it acts as a powerful oxidizing agent. Under the action of ozone, a shining silver surface blackens rapidly, being covered by a layer of silver peroxide, Ag2O2. When ozone is passed through mercury, it loses its meniscus and sticks to the glass due to formation of Hg2O, which dissolves in mercury. This phenomenon is called tailing of mercury. Uses of ozone. The important uses of ozone are following. It is used as deodorant to destroy odor in kitchen and restaurants. It is used for bleaching oils, flour, starch, and ivory. It is used as germicide and disinfectant for sterilizing water. It is used in the manufacture of artificial silk and camphor. Allotropic forms of sulfur. Rhombic sulfur. This is the most stable form of sulfur. It is obtained by slowly evaporating a solution of roll sulfur in CS2 when octahedral crystals of rhombic sulfur are formed. This is lemon yellow in color. Monoclinic sulfur. If crystals of rhombic sulfur are slowly heated to 369 Kelvin, they slowly change into needle-like variety called monoclinic sulfur. This form is stable above 369 Kelvin. It has dull yellow color. It is insoluble in water. At 369 Kelvin, both rhombic sulfur and monoclinic sulfur coexist, and this temperature is called transition temperature. Sulfur dioxide. Sulfur dioxide can be prepared by burning sulfur. In laboratory, it is prepared by the reduction of H2SO4. Metals react with hot and concentrated H2SO4 to form SO2. On commercial scale, sulfur dioxide is obtained by roasting sulfides. Roasting means heating a metallic sulfide in presence of air or oxygen and converting sulfide into an oxide. Properties of sulfur dioxide. It is a colorless gas at ordinary temperature and has disagreeable and suffocating smell. It reacts with alkalis, forming sulfides and bisulfides. In the presence of moisture, it acts as a bleaching agent. It is quite soluble in water and solution is acidic. It acts as a strong reducing agent in aqueous solution. It acts as a good oxidizing agent. For example, at 1000 degrees Celsius, it oxidizes carbon into CO2. Uses of sulfur dioxide. The important uses of sulfur dioxide are following. In the manufacture of H2SO4, H2S, and calcium hydrogen sulfide, which is used in paper and pulp industry. It is used as an anti-claw and disinfectant. It is used as a preservative for canned food. It is used in refining petroleum and sugar. It is used as refrigerant. It is used in bleaching. Oxo acids of sulfur. The sulfur oxo acids are chemical compounds that contain sulfur, oxygen, and hydrogen. Sulfur forms a number of oxo acids. Some important oxo acids of sulfur are the following: H2SO3, sulfurous acid; H2S2O4, diathenious acid; H2SO4, sulfuric acid; H2S2O3, thiosulfuric acid; H2SO5, permonosulfuric acid; H2S2O8, per-disulfuric acid. Some of these acids are unstable and are known in aqueous solution or in the form of their salts. Let us summarize what we have learned. The elements oxygen, sulfur, selenium, tellurium, and polonium constitute group 16 of the periodic table. Elements of 16th group have relatively high electron gain enthalpy values, which decrease down the group. Oxygen molecule is diatomic and under normal conditions exists as a gas, while other elements have larger atomicities and exist as solids. Oxygen shows oxidation state of -2 in its compound, while other elements show additional oxidation state of +2, +4, and +6. A binary compound of oxygen with another element is called oxide. Oxygen combines with most of the elements to form oxides. Ozone is allotropic form of oxygen. Under certain conditions, 3 atoms of oxygen combine together to form triatomic molecule of ozone. The sulfur oxo acids are chemical compounds that contain sulfur, oxygen, and hydrogen. Sulfur forms a number of oxo acids. Concentrated sulfuric acid has a great affinity for water. Its dissolution in water is highly exothermic in nature.